Hello everyone, this is Son of Winter. I'm here today to make a prediction for 2022-6092 GCE O-level chemistry paper, the Singapore version. I'd like to emphasize that whatever I predict here will not necessarily means it will be tested. It is just my own interpretation and prediction of the upcoming O-level paper in November. All right. So before I predict what might come out, maybe we can take a look at what came out in 2011. So I'm just going to focus on paper 2 and paper 3 because it would be better if I can predict paper 1 right after paper 2. Yep, it will be a better gauge. So what was tested in 2021 paper 2 was the reactivity of group 1 and group 7 elements. So students or candidates need to exhibit understanding on the trend of reactivity down group 1 and down group 7. So down group 1, the elements are more and more reactive. Down group 7, the reactivity decreases. And students need to know how to test for chlorine. Last year, QA was tested for practical, so we don't see a lot of QA questions in the theory section. Students are required to remember the test for chlorine, which is used to bleach damp red litmus paper or blue litmus paper turn red before it bleaches. And students need to exhibit knowledge on the properties of transition metals where they form variable oxidation states in compounds. Students need to exhibit knowledge on the different types of oxides. This is a very popular concept that are tested either in paper 1 or paper 2 every year. And students will also access on the electronic configuration of atoms and ions. And of course, periodic trends where students need to choose true or false about the trend of melting point across a period or other properties related to group 1, group 7, and trends across a period and down a group. And then they were also tested on the fractional distillation of petroleum. Mainly, they need to describe the whole process, starting from how the liquid petroleum was heated in the furnace before it vaporizes and separated into fractions in the fractionating column based on different boiling point, where the fractions with the lower boiling point will be collected at the top and the fraction with the highest boiling point collected at the bottom of the fractionating column. And the physical properties of each fraction was also tested in last year's paper, where they were required to explain why butane and propane were found in the same fraction, because they have very similar number of carbon atoms and they have similar boiling point. Okay. Now, there were quite a number of questions involving organic chemistry, which include the molecular formula and empirical formula. So students are required to remember the molecular formula of some organic compounds and derive the empirical formula from there. The question was related to enthalpy change of combustion, the topic on energy changes, where students need to exercise knowledge or conceptual understanding that the enthalpy change of combustion is related to the different number of carbon atoms in organic compounds. So students were required to show understanding that with a higher number of carbon atoms, more carbon dioxide will be formed, and hence more bonds are formed. And by calculation of the amount of energy released from the bond forming of CO2, as well as H2O, because the hydrocarbons include both carbon and hydrogen. So more bonds form, more energy release, which result in a higher enthalpy change of combustion. Last year, students were not tested on the calculation of enthalpy change of combustion using bond energy. That was not tested last year. And students were not required to draw energy profile or energy level diagram or state examples of exothermic and endothermic changes that were not tested. So this year, there is a chance that this learning objective or outcomes will be assessed. Instead, last year, the calculation of enthalpy change of combustion involving conversion between mass and moles were tested. The next question is on electrolysis, where students are to determine products for different types of electrolyte and electrode with explanations, observations, and writing half equation. So it's a very standard electrolysis questions. Okay. And then the blast furnace in extracting iron, listing the compounds and mole calculations with concepts on how impurities will affect the yield. Okay, that is tested. But then they never really go very deep into the blast furnace. They went on to talk about how impurities affect yield and the calculations that is related to it. All right, then composition of air was included as part of the blast furnace question, and students need to explain the composition of air in blast furnace based on knowledge of reactions. Like nitrogen was found in high percentage because nitrogen was not involved in reactions in the blast furnace in the extraction of iron. There is a certain percentage of CO2 and CO formed because of the reactions taking place. So they need to write down or even show equations to explain how these gases come about in the outlet of the blast furnace. Purpose of adding different carbon to iron. So why, the question was asking why you need to use different amount of carbon to add to iron, etc. Dot and cross diagram of urea was tested. So we can expect something more challenging to come out this year as well. In previous year, students were required to draw dot and cross diagram of a polyatomic ion. If I'm not wrong, it's ClO minus. So they could, but from what I observed, they try to avoid asking students to draw dot and cross diagram involving structures that doesn't obey or violate the octet rule. They try to avoid that. Okay, so the question will likely be something related to octet rule, meaning the octet or duplex structure, meaning the atoms forming the molecule in a covalent bond will follow octet or duplex rule. All right, duplex if it only have one electron shell, octet if it has 2 or 3 electron shell. So they try to set question within that parameter. Students are required to show knowledge on how formation of gas products will lead to possible explosion. All right, so something about that was tested, and knowledge of air pollutants and why it's important to remove them, like we want to avoid SO2 because it will cause acid rain, blah, blah, blah. And also the knowledge on greenhouse gas like carbon dioxide and its impact on global warming and effects. Writing overall equation seems to be more and more popular in recent papers, so please take note of that as well. Now, followed by more calculation to determine concentration of solution. There are quite a number of calculation questions in this paper. And we have a database question on acids, but not titration curve this time around. So likely that this year database question is not on acid bases. Yes, it's not acid base, but it could be salts, but it's definitely not on the concept of all this, like knowledge of monobasic, dibasic, tribasic acids, relationship between pH and concentration. So they ask a very interesting questions. In fact, it's like a mathematical question, like pH is inversely proportional to concentration. Is it true? Something like that. Based on the data given in the question, it is not true. Then you have to justify using the data. Why is it not inversely proportional? So students need to show understanding of what is directly proportion and inversely proportion. Directly proportion means, right, let's say you have two values, right? Then if, let's say if X and Y, if you say X and Y are directly proportional, it means that when X times 2, Y should also times 2. That is called directly proportional. But if X times 2, Y times 5, then X and Y are not directly proportional. Okay. Likewise, if you say X and Y are inversely proportional, so if X times 2, Y should times half and not times other value or divide by other value. All right. Now, students will also access on the factors affecting pH like strength, concentration of the acid and basicity. So these are the factors that affect pH. And the organic chemistry question focuses more on polymer that year with calculations of MR of repeating unit. Both addition and condensation polymerization knowledge is required for this paper. And of course, there is a question regarding oxidation reaction of alcohol. You will notice that in this paper, there is not much question on alkane. In fact, there's none. It doesn't appear in paper 2. So this is something I want to predict for this year. And the difference and similarity between condensation and addition polymer. And there is a chance that this year database could be organic chem. Then finally, we have the question on reactivity of metals with carbon with regard to ability to reduce a compound and change the oxidation state. Then we have more questions like bonding and structure for all the types. Giant metallic lattice structure, it came out. Giant molecular structure using silicon dioxide as an example, it came out. Carbon dioxide simple molecular structure. All right, the only one that was missed was giant ionic lattice structure. Okay, they also talk about, I think, why the melting and boiling point is different, and even electrical conductivity. So it's a very long question of 5 marks where they give a lot of lines to allow candidates to finish. If they cannot finish the question within that space, you can write behind to continue the answer. And this type of question, percentage composition calculation, the database indirect question is super popular. So other than combining two half equations to form the equation or combining 2 or 3 equations to form an equation, this is the next popular type of question that seems to appear in recent paper, where students are given, let's say, a data, and they're supposed to verify, let's say, this compound belongs to which one based on the data. So they're supposed to do some calculation on percentage composition in this case, and from there they deduce what could that be. So it will not be a direct question where they say, oh, calculate the percentage composition as what you see in your textbook. No, this type of question will not appear. What will appear is indirect question. So they have, they give you a table of values, and then they'll ask you, based on the value, do you agree, show with calculations and explanation, something like that. The concept of controlled variables in speed of reaction and coating of data is tested for this paper, as well as collision theory to explain the factor. But this time around, I think they asked quite a lot. Concentration, temperature, and I think surface area. Also a 5 marks long question. And the last question is a mole concept question where students are assessed on the concept of limiting reagent. But this time around, one of the reagent is given both concentration and volume. It's a solution, so it's a bit different from usual lah. Okay, so that was tested in 2021. How about in 20? So in all, right, the popular topic that were tested in paper 2 was electrolysis, mole calculations, bonding and structure, acid and bases, speed of reaction, energy changes, organic chemistry, which focuses on polymers and fractional distillation, the blast furnace and reactivity series, air, pollutants, and greenhouse gases. So for 2022, my prediction would be the following. I am taking a bold step to do this because I've not seen this for some time. So I'm predicting that this might come out, but I'm not saying it will come out. I'm just saying students are to be prepared for this. Okay, so what I can say is whatever that was tested in 2021 will not be repeated. That's what I can say. Okay, the same question will not come out. So you won't see a database question on acid basis. No way. You won't have a question that say, what is the difference between addition polymer and condensation polymer, which they asked last year? No. You have a question to say, why different carbon need to be added to the iron to make different alloy? No. You have a question that say, asking you to label the parts in blast furnace? No. Okay, so something like that will not be tested. That's for sure. Because when they vet the paper, they will try to avoid repeating the question last year. They may repeat parts of it in terms of the learning outcomes. The learning outcome may be repeated, but not the format of the question. Okay, but certain learning outcomes, right, can only be tested in certain way. For example, if you want to test students on knowledge on blast furnace, right, you want them to label the parts. Where are they? There's only one way. So if they already test this, then they will not test again, because certain learning outcomes have limited way of testing. But certain outcomes, like for example, percentage composition or empirical formula, that you could have different ways, you see. You could have different examples. So this type of learning outcomes, right, can be replicated, can be repeated, tested again. But certain outcomes, right, which is quite limited in the way they said, then it's very hard for them to repeat that. Now, yes, there will be some questions, but on a smaller scale in bonding and structure. I don't think they will set so much in paper 2 this year. Yeah, given that they actually pump in a lot last year. More calculation will always be tested in a certain percentage. It may be more or maybe less, but definitely tested. And my focus will be more on percentage purity, empirical formula, and use of the formula. And maybe I may also look at back titration as well. Something that's quite unusual. It may be tested. Salts preparation, this is not tested at all for last year paper. So this year, please know the 3 methods very well. Please. And QA. Yes. Do pay attention to salt preparation, precipitation, titration, and reaction of metal or carbonate or base with acid. The questions related to try to practice for all that. Periodic table trends. Metals this time around focus on rusting, corrosion, recycling, or metal displacement reactions, reduction reaction, as well as I think the properties of metal in terms of why the alloy is stronger and harder than a pure metal. It came out a few times, but I would think that it may be tested in a different format. For example, they may ask you to, but that tested before, like they will ask why this particle representation is wrong. Yeah, something like that came out 2-3 years ago. So they may have a question on that, but they may ask indirectly, okay? Air is on a smaller scale this time around, but do focus on biofuel and carbon neutral fuel. So they may ask a question on what is carbon neutral again, like what they did 12 years ago. Then organic chemistry this time around focus more on alkenes, alcohol, carboxylic acid, ester, but smaller scale in polymer. They may not even have a question on polymer. Let's see how it goes. Electrolysis, including questions like electroplating, purification, but I feel that they won't ask too much this time around for electrolysis. They may even have simple cell, okay, or energy fuel cell, I suspect. Redox, yes, not much in 2021. Get ready OA-RA color change, or have a question on explaining the why is this substance an OA or RA, and explain in terms of oxidation state or even electron transfer. Energy change, yes, speed of reaction on a small scale, and definitely Haber process. As for paper 3, it's harder to predict actually, because the topics are easy to predict, but not the exact way. But if they ever come out titration, then there's a few: redox titration, or the iodine with thiosulfate, or it could be something else, okay, acid base or some other reactions, but it will be all similar lah. Or maybe thermal titration this time around, and which they tested in 2018, I think so, or 19, something like that. Yeah, 2019, sorry. Yeah, but they may test again this year. QA on a smaller scale, since they test quite a number this past 2-3 years. Energy change, where they need you to measure the temperature and then plot a graph. Speed of reaction, use of stopwatch. Mass change, planning question, a bit harder to predict for the planning question because really there's a wide variety of questions. Maybe a speed of ration or percentage purity, or could be anything like maybe find out whether this substance is a more effective catalyst, or find out which metal is more reactive, or which carbon is more stable, or maybe go ask about rusting. For example, let's say you have two iron, which one corrode faster? Then how do you measure? Something like that. It's a bit weird, but sometimes they may have such questions. Like for example, you have two metals, you do not know what they are, but you want to find out which one corrode faster. So how do you go about doing it? So you have to think about control variables, dependent and independent variable, your measurement method, what data are you collecting to make a fair comparison between these two metals. So maybe you want to talk about measure the mass, and then measure the mass before and after, putting them in maybe the same amount of water exposed to the same amount of air in the same environment, and then you measure the mass, because if the metal that corrode faster within the same given amount of time, the mass should increase more. But then now maybe they will give you the identity of the metal. Then you need to, it's not just the mass, but also have to consider the mole, something like that. And then it could be a 3 practical tasks plus 1 planning. That's my prediction. So that's it. I hope it helps you to prepare for your end of your practical exam. This is the first time after COVID pandemic that a full paper will be completed. So all the best to the students, and thank you very much.